Hi, Assalamualaikum and good morning everyone. Today our group is going to present our project which use teachable music to identify oral health condition based on image or text. So before we start our presentation, first let me introduce myself. My name is Zulfa Husna Fitri Helmi and this is my team members. First, Muhammad Isa Zahani bin Sobri. Second, Intan Nur Soleha binti Ismail. And third, Nur Iza Khalida binti Khaludin. And the last one is Iwani Aisyah binti Azhar. So for the introduction, we choose this topic because oral health is very important, but many people often ignore dental problem until they become serious. Therefore, we wanted to explore how artificial intelligence can be used to help identify whether teeth are healthy or unhealthy. So for this project, we use teachable machine, which is a machine learning platform that allow us to train an AI model using image without needing complete coding skill. So the main objective of this project is to demonstrate how AI can be applied in the healthcare field and how it can help to raise awareness about oral health in a simple and accessible way. So let's begin our presentation.
My name is Iwani Aisyah binti Azhar. My matric number is B03251067. So I will be presenting the objective of our project. The first objective is to develop an AI model that can recognize the different oral health conditions from the image. The second objective is to provide user with early detection of potential oral health problem. The last objective is to create a free and user-friendly tools for user to monitor their oral health regularly. For the framework, the AI-based oral health system framework is designed to automatically identify and classify a user oral health into three categories, which are gingivitis, potential cavities, and also healthy. So the main goal of the oral health detection is to provide general user with a simple tool to detect potential oral health problems early. This also helps them to detect dental issues before they get worse. This tools is user-friendly so that anyone can use it easily. The framework is divided to three main parts. The first one is data input. Data input handles the permission to access webcam on user's device or to open the file explorer so that user can upload their oral image. It will convert the image into a readable format that computer can read. And then for the second one is model processing. The model processing is the core for backend where the trained convolutional neural network CNN runs. It processes the image by scanning the visual features like color and shape to compare healthy teeth and also teeth with the issues. The last one is output. Output is where it connects the AR result to the user interface. It will then automatically display the probabilities into the percentage bar, giving the user a clear answer about their oral health status. This is our architecture framework diagram for the AI-based oral health system detection. The process will begin with the user's input, which will be provided either by uploading the existing image from their device or by capturing the live photos or videos using the webcam. These inputs then will be received through the front end for our head detection interface. This front end will receive it from the user's interface. Okay, so once the front end interface send the input image, it will directly go into the backend CNN model engine that was built using the Google Teachable Machine. This engine is powered by the training data, which means the model is trained so that the data the training so that it can recognize the visual of the dental features accurately. This model then will process the image data and display the result and by classifying the user or head status into three categories, which are gingivitis, potential cavities, or hete.
Assalamualaikum and hi everyone. My name is Nori Zakalita binti Khairuddin. My matrix number is B032510623. So next, I'll be presenting about our proposed predictive modeling. So first, let's trace how the user experience in our system. So as shown in the slide here, this is our operational workflow of our health detection system. So first, we start when the user capture the live dental image using their webcam or uploads the existing photo into our interface. Then the input will immediately trigger the pre-processing stage where the image will undergo sizing adjustment and pixel normalization. Then once everything is prepared, the normalized data is sent to our teachable machine backend where the CNN extract the key color and control feature. Then the final step is the model output is that it will classify and mapping the probability results across our three target metrics, which are healthy, gingivitis, and cavities. So in the slides, I will be presenting our predictive model that is divided into three primary functional modules. The first one is that we have our image acquisition and pre-processing module. This is to make a dental screening highly accessible, and our system allows user to capture a live photo using their webcam and upload a high resolution image. And because of the different and diverse device used to capture the photo, it will, with the verified resolution and lighting, this module will automatically resize and normalize the pixel data to ensure that input consistency before sending it to the backend. Then next, the second module is that we reach the core of our intelligence system, which is convolutional neural network (CNN) model engines. This is powered by the Google Teachable Machine that this engine was trained on categorizing tooth profile. So when a user normalized image enter the engine, our CNN scans a visual feature for color variants, such as localized redness from inflammation or dark decay spots, and structural shape anomalies along the gum line and enamel. So the final module is the third module. We have the output classification and visualization module. So once the CNN completes its scan, it will generate the probability scores. And this segment will score it into three distinct health states, whereas it is healthy, gingivitis, or cavities. So then it will translate those complex decimals into responsive, user-friendly percentage on the dashboard.
Assalamualaikum to Dr. Norizam. My name is Muhammad Izzat Zayani bin Sobri and my metric number is B032510780. So moving on to our system design, I'd like to walk you through our dashboard architecture. So now let me explain how our dashboard architecture works. As you can see in this diagram, our system is designed to be simple and easy for anyone to use. A user starts by uploading a photo or using their webcam to take a picture of the teeth. Once the image is ready, our front-end application, which is the main dashboard you see on your screen, takes the image and sends it over to our backend. The backend is powered by our teachable machine model. This is the brain that looks at the picture and decides if the teeth are healthy or have cavities or show signs of gum diseases. This model runs right inside the user's web browser, which makes the results show up almost immediately. Finally, the backend sends the classification result, which is the percentage score. So back to our dashboard to show the user the final result. We design it this way for two main reasons. It makes the system very fast and it keeps the user's photos private because the images are processed right on their own computer, not on our server. Alright, now let's look at the three main parts that make our dashboard work, which we call our functional modules. First, we have the data input module. This is the part that talks to the user. It makes it very simple. for the user to either turn on their webcam to take a live picture or upload a saved photo from their computer. Second, we have the communication module. You can think of this as the messenger. Its job is to take the image the user provided and send it securely to our model to be analyzed. Finally, we have the visualization module. Once the model gives us the results, this module takes that information and shows it to the user in a way that is easy to understand, using the percentage bars to show the health assessment. All right. Finally, I want to talk about why we designed the system this way, specifically focusing on our system standards. So for the performance, we made sure the system works very fast because we want the user to get their results immediately. We optimize the code so that there is no waiting time when the image is processed. For the privacy, this was a top priority for us. Since photos of someone's teeth are very personal, our system processes everything right on the user's computer. The photos are not saved on our server, which keeps the user's data completely private. For the accuracy, we also worked hard to make sure our results are trustworthy. We tested the system many times to ensure the percentage scores shown on the screen correctly match the health category of the teeth, so the user can be confident in the feedback they receive.
Okay, so hi, my name is International Binti Ismail and my metric number is B0325106110. Okay, so my part is design and discussion. For the first one, the class name have a three, cavities, pointational cavities, and healthy teeth, which is every category have 20 picture, 20 raw image collected, and with final post-processed image with 20, and the final resolution of every categories is 224 x 224 pixel. So the total image that used in is 60. Okay, so the first test picture is the first output image is split confidence score of 42% of healthy, 34% of cavities, and 34% potential cavities, which is this confidence score is depends on what element that we add in every class. Every class cavities, every class potential cavities, and the class of healthy. Okay, so next for the second test image, the T that have cavities is categories on potential cavities, which is the confidence score is 99% and the 1% is on gingivitis. So next, last test of image is healthy T. We can see the T is clean, no gingivitis, no potential cavities. So the score is 100% under healthy class. Okay, so for the discussion, the system is highly sensitive to visual variation but currently lacks the deep diagnostic step. So, while the system serves as an excellent, low-cost and fast prototype, but it still cannot replace a professional clinical examination. Means, even we provide a tools to recognize the picture of image in which class or which category, but still the perfect result is on professional medical.
Okay, so now I will demonstrate on how our teachable machine model works. So for this project, we train the model using three categories of oral health condition, which is hepatitis, the second potential cavity, and the third is gingivitis. So to test the model, we have prepared 6 different images of this with different conditions. So I will upload each image to the system, and the model will analyze the image and predict which categories it belongs to. Okay, so for the first image, so we can see the model classified the image as hepatitis because the teeth appear clean and show no obvious sign of disease. For the second, for the second image, for the second image, the model classifies it as gingivitis because The image is associated with inflammatory redness on the gums. For the dead image, the model also classifies this as gingivitis and detritus. Oh, for this image, the model classifies is gingivitis and potential cavities. Yeah. So, as we can see, the model is able to distinguish between the three oral health conditions based on the image provided. Okay, so now I will demonstrate on how our teachable machine model works. So for this project, we train the model using three categories of oral health condition, which is hepatitis, the second potential cavity, and the third is gingivitis. So to test the model, we have prepared six different images of this with different conditions. So I will upload each image to the system, and the model will analyze the image and predict which category.
So in conclusion, our proposed AI-based oral health detection system provide an accessible tool for early detection for oral health. Using the image classification model, the system can categorize the oral health condition for each user. This allows users to monitor their dental and oral hygiene at home. This also shows how an easy accessible tool on browser can raise awareness to people about the importance of early oral care, allowing the user to take an action before their oral health condition worsen. That's all from us. Thank you.